So as quicker you acidify, you will have less and less color and flavor. That's mainly driven by the fact that the acid is restricting the staphylococci.
Hello, meat folks. Welcome back to the MeatsPad podcast. Today, we're doing it a little bit different. We have here on my left, Austin Egolf, our food scientist here at Ultrasource. How you doing,
I'm
Austin?
doing pretty well. Thanks for having me, Francisco. It's been a long conversation to get here, but I'm glad to be on finally.
Oh yeah, and absolutely. I think we've me and Austin been talking about casings, talking about many topics, and I think it wasn't not until today that we had our guest here at Ultrasource talking about startup cultures, and we welcome Joerg Duepjan and François Desroches. Welcome.
Thank you. Welcome.
Thank you, Francisco. Glad to be here.
How do you guys like Kansas City?
A very nice city. I was not sure what I should expect, but it's a very lovely town, and also looks nice. It's really, for me, for a German, it don't looks too American, I would say.
I wish we recorded some of the things we did this morning in the kitchen. We were doing some pepperoni. Tell us, Austin, what did we do in the morning?
Yeah, so this morning, Joerg and François are both from Lallemand specialty cultures out of France. And we have some of their cultures, and they came over to kind of give us a lesson on how to use them. So this morning, we made dry-cured bacon with one of their cultures. And then we also did sweet Lebanon bologna as well as pepperoni. So we're going to ferment both Lebanon bologna and the pepperoni with an internal meat ripening culture. And then we used a surface culture for the dry-cured bacon to help improve color, antioxidant capability, so shelf life, and to kind of help improve texture a little bit. So we did that this morning, and currently they're in the smokehouse. The bacteria is doing its thing, and we're hanging out talking about cultures.
One of the things, like I was impressed by the knowledge of these guys. A lot of the times we think like, okay, we got all the science and all that figured out, and then we started talking about all the things that you've done and all the companies you work with and the plans you've been at. It was kind of funny because you told me about your company and on the wine thing, that I found that very interesting, that mostly your business is in the wine. Can you tell us about your company, what you guys do? I think you said like for every, how many bottles you guys are in from that perspective, from the startup culture, for 4 every, I don't know, what was that?
3 or 4 with Lallemand cultures, in case cultures are added to the wine. So Onology is one of our, it's a rather new business unit, because before wine was done like beer with baking yeast, so just to produce alcohol. But during the time it became more specialized, and Lallemand invested in that field and created new, better cultures, more tailor-made cultures for Onology applications. And now we are clearly market leader, and it's a good growing market. The wine consumption is going up mainly in COVID, so for the people compensating something. So no, it's really an interesting company. Also, all of Lallemand, because Onology is one business unit. We have around 15 business units. We do all bacteria and yeast for 15 different applications in food. So. And we are structured like that because we need to be expert in that what we are doing. So I cannot do the wine, I cannot do the beer. I can drink it, but I cannot do it. I'm for the meat. The others do animal nutrition, probiotics for human, for pharmaceutical bacteria, so living bacteria for pharmaceutical applications. So it's quite funny because we are 4,700 people. And we do something you cannot see in a single form, because the bacteria you cannot see. Yeah. And 4,700 people in the world working in 48 plants around the globe for us, and doing something for food and to make life better and more stable and more nice.
One of the things that you think this way, we 4 people on the table, Germany, U.S., Mexico, and France. How are you, François? You haven't said anything. I think he's a little bit nervous, but it's okay to be nervous. I think, can you please introduce yourself, a little bit about what you do? You've been in the States for 20 years. Tell us a little bit about who's François.
Yeah, that's correct. So I arrived in the US, specifically in Minneapolis, Minnesota, 20 years ago. Initially working for a French company in the field of sanitation and food safety. And I recently joined Lallemand and Lallemand Specialty Culture. My experience is with the cheese processing industry, so providing cultures to age cheeses, to ripen the cheeses. And I learned tons in the past few days with you guys. I enjoyed a lot making the meat products this morning. That was really an incredible experience for me. So thanks for having me again.
Oh, thank you. And we'll see how they turn out tomorrow morning, right?
Yeah, tomorrow morning will be the day.
Yeah, that's the good thing about meat science, that you get to taste what you produce. So, I have 4 different questions that it's more like a follow-up questions from this morning, and one of that will be talking. Maybe you can tell us about the main difference between an emulsion and I mean, in terms of mixing and fermentation. We're talking about how you need to add salt last when you're fermenting product. In this case, in the morning we do pepperoni. So tell us a little bit about the rationale behind that. I think it's good because a lot of our listenership is meat processors, specifically small and meat-sized processors in the United States, and some of them are wanting to learn more about how do you manufacture a fermented product efficiently. So I think there's very good information and very good opportunity for some tips.
Mm-hmm. Yeah. So when you want to do the meat matrix for dry fermented, it's very important to add the salt at the last possible stage. So only the rounds where you need for distribution of the salt, but not earlier. When you add it too early, you activate too much proteins. You make the proteins able to hold the water. And during ripening, you want to lose it. So you create an own hurdle. And also, you want to lose the water that the bacteria slows down the working. So when the water is longer in, the bacteria works longer. And that's not the aim. That's not the plan. Also, you lose days of ripening because when your target is to lose 30% of water, and you add the salt too early, could be that you need 32. That you need two or 3 days longer than normally. In Germany, we do the quickest product has a fermentation time of 11 days, so that's good to the market in 11 days. When we would add the salt too early, we would not reach the target of these 11 days. We would need 13 or 14, and it uses to explain what that means for the capacity. So you waste money, you block your capacity only because you added the salt as a first ingredient. So it sounds so simple, but salt is just there for the flavor, and you need only 3, 4, 5 rounds at the end to distribute it. That's the only purpose. You add it too early, you activate the proteins hold the water, you can create a mess. And that can also result in a lot of different defects at the end.
One of the things that, for some of the folks that heard ripening, and we're discussing that term because in Germany you use ripening to talk about aging, correct? And not fermentation. So yeah. Will you please elaborate more on that?
Yeah, so when we talk about fermentation, for me fermentation is for sure the metabolism of the microorganism, sure. But for me fermentation is also when we produce the bacteria. When we go in the meat matrix, I want to ferment, yes, but I want only the metabolism. I don't want the bacteria at the end anymore. So I don't want to harvest it. So for that reason, for me, it's more ripening, maturation. I need the bacteria, only the metabolism, that they give me the organoleptic profile at the end I want, and the enzymatic activity. And for me, fermentation is the whole metabolism, sure, But in the German wording, then it's more the fermentation is the production of the bacteria to have as maximum CFU, colony forming units per gram. So
You said enzymatic reaction?
also. So you know that you have a lot of food enzymes to force something or to make something happen. That's clearly, for me, an additive. It's an additive because you can calculate, it's mathematic. You add this amount of enzymes and you will reach that. With bacteria, it's a little bit different because we need to motivate them to do it. We need to give them the conditions. We need to give them the food. So the nutritional complex, like yeast extract. They are very attracted by yeast extract because we use yeast extract during the growth, during the production of the bacteria. And then we give them the possibility for us to produce these enzymes, like catalase, for example. Nitrogen reductase activity is enzymatic. And all the time when we produce these enzymes, not we, the bacteria, it creates flavor. So for example, when we do a dry fermented and starting with nitrate instead of nitrite, we reduce the nitrate to nitrite. That gives already enzymatic activity, creates flavor. Beside, it improves the color. So you get a more dark color, a more red color. And when we have then the nitrite, the NO2, we go down to nitric oxide. And also that is supported by the bacteria, not only by ascorbic acid or ascorbate. So, and then we create additional flavor. So when we do these 3 steps, we have more flavor due to the enzymatic activity of the microorganism.
So you kind of touched on it a little bit there, like the environment that the culture needs, that the bacteria needs, the parameters. Could you talk a little bit more about what those parameters are, like chamber temperature, humidity, all those types of things, airspeed, all those? Not all of them, but like the main big ones that the listeners who are trying to do, a ripened product, what they need to consider whenever they're going through the process after.
Mm-hmm. So actually there are two different ways to do it. So there's one the American process and the European process. The American process, probably you will need to help me with the Fahrenheit because my brain works in Celsius. So the American process is more fermentation around 45 degrees Celsius. So we call it high temperature fermentation because when you would go even higher, you come already that the protein could coagulate, and then bacteria has a part of protein, so they could also die from the heat. So that's the reason that the maximum for fermentation, for ripening, should be 45 degrees Celsius.
So for all the folks who use Fahrenheit, that's like 100 to about 115 degrees Fahrenheit.
The European process is much colder. So it's a wide range in Europe. We have a lot of different countries and cultures. So we have fermentation temperatures between 18 to 30 degrees Celsius. So that's rather cold. We use a little bit of different bacteria for that. We use more lactobacillus instead of pediococcus. American process is more with pediococcus, and our process is more with lactobacillus. We have some pediococcus, but there's another part, the staphylococcus. And these are really the ones, the secret heroes of the fermentation, because they give all the color, all the flavor. And the lactic acid bacteria, the lactobacillus, is only to drop the pH.
Gotcha. So for those cooler temperatures, that'd be somewhere right around that 60 degree to like about 8 degree Fahrenheit for those fermentation temperatures. So what's the difference? So you have higher temperature and lower temperature. How does that impact the drop in pH in regards to how quick the fermentation process happens and what the pH looks like and how that then impacts flavor and color and all those types of things?
So as quicker you acidify, you will have less and less color and flavor. That's mainly driven by the fact that the acid is restricting the staphylococci. When we talk about the American process with 45 degrees Celsius, you use a pediococcus acidilactis, and that one is known that it's a very strong acidifier, very, very quick and strong. So that means that we can acidify to a pH of 4.6 in 15, 16 hours. In the European process, we talk more about days instead of hours. When we ferment, for example, it's even the range 18 to 30 degrees. That's already a big range. We need to treat the bacteria nice, and because otherwise it will not give us back what we want. So when you ferment at somewhere in the middle, 22, 24 degrees Celsius, a quick fermentation is still probably 36 hours, 48 hours, so 2 days. The benefit is you have much more color and flavor. All the time, when you go quicker, you lose organoleptic profile.
Wow.
And also when you punish the bacteria, the lactic acid bacteria, they are able to produce acetic acid, and acetic acid takes all your flavors. Acetic acid is extremely strong on the tongue, so it's directly at the front of the tongue, the acetic acid, and then it blocks all fine flavors. So when your bacteria produce fruity notes, buttery notes, some yeasty notes, they are all blocked behind the acetic acid. So treat the bacteria nice, it will produce a clean lactic acid. Clean lactic acid is neutral for the human tongue, and everything is nice. You have a very nice product, nice organoleptic profile, no problem that the color collapses because of the acetic acid. The bacteria is happy, and later the producer also.
Yeah, what are your thoughts? And I really want to follow. I got like 10 questions from these comments, but I think that one of the big ones, and a lot of people out there, they use GDL or some kind of, we had, or lactic acid. So what are your thoughts on using some of the difference? Because I know you mentioned you can use both sometimes. So maybe you can tell us more.
You can. So first, I'm not a friend of that because it's a chemical acidifier. For me, it's not, has nothing to do with fermentation. It's not a fermentation. You acidify something. Sure, when you don't have the equipment that you can make a fermentation temperature, that you cannot reach it when you need to do it cold, then it's a way to do. When you use it, there's still the option that you can combine it with staphylococci, because the acid is produced or comes from the GDL, or citric acid, but that gives not anything for the flavor profile. It's just the acid. For the flavor profile, you can still add bacteria, because staphylococci is active also at cold temperatures, so close to 0 degrees Celsius. They can have a metabolism, for sure it's slow, but you improve your product because you will have a stronger color, and you can produce flavors inside.
And you still need to ferment for 36 hours? Or
no,
would you recommend this?
Them, and then you start your drying, because they work the whole time. The staphylococci works the whole time.
So would the staphylococci be killed by cooking temperatures like 160 degrees Fahrenheit, or would they just be inactive and then they could kind of reinvigorate while they were drying? So typically, the citric acid or lactic acid is typically going to be used in more of a snack stick or a summer sausage type product, kind of try to get quick throughput, drop pH, get kind of a tangy flavor. But then it's also usually fully cooked to, for the USDA guidelines, it's 158 degrees for 0 seconds, or you could do some time temperature combinations. Mm-hmm. Usually those oven temperatures are around 175 degrees Fahrenheit, so that would be around 75 to 80 degrees Celsius. Mm. So would the staphylococci be able to hold up under those temperatures and then be able to kind of regenerate and help some color and stuff formation?
If one option would be you give it a day resting, so that you get color and flavor, and then you cook. Because when you go to these 80 degrees Celsius, that's a hard thing for the staphylococci. When you go 72, that they can survive. They will be inactivated the first 3, 4, 5 days after cooking, because it's stress for them, clearly. But we did trials for a different system, and we recognized that at T1, 2, 3, 4 after cooking, you don't find any staphylococci, and then after day 5, 6, 7, they recover, and they have a metabolism again. And they do nothing negative in your product. They cannot produce gas, they cannot produce acid. They have catalase, they are catalase positive, so they are able to split up hydrogen peroxide, so you reduce the risk that your product will be rancid.
Okay. I think
that's too much.
Can you repeat that again? Because I think that's so important. So can you repeat that last part? Like, even 4 or 5 days later, they can still be working to help for that as an antioxidant.
Mm-hmm. Yeah, exactly. So they are inactivated due to the heat, clear. When you go to 80, a lot of them pass away, so you decrease the population a lot. When you only go to 72, a lot of them survive. It's a cocky, it's small and round, has a very strong cell wall, is very, very robust. And as soon as they get active again, they start the metabolism because they still have everything they need. There's humidity, there's, the salt is not a problem because they're highly salt tolerant. They are, even in the labs, they are easier to count when you put salt in the media. So we count our Staphylococcus and we add 6% of salt to the media because then you can count them reliable. Without salt, you cannot really count them because you have less colonies. So they are attracted by salt. That's the reason even when you dry a bit, the activity is better compared to be worse, only because the salt is higher.
So they like salt.
They love salt. They love salt. And they're also quite robust for nitrate and nitrate because they have nitrate reductase activity. So they can reduce it by themselves when they don't like it. And as soon as they start to be active again after these 3, 4, 5 days, they start their metabolism. And one of their metabolism is that they are catalase positive. So they produce the enzyme of catalase. And that can split up hydrogen peroxide. And that reduces oxidation. Mainly when we talk about meat products, for sure the fat oxidation, because that's normally the weakest part in the meat mix.
So that's why you mentioned optimizing shelf life by using them.
It's important stuff. I mean, that's like you could put BHA and BHT on your label, which is butylated hydroxyanisole or butylated hydroxytoluene, and those are typically found on your labels to help stop oxidation. And in the day and age that we live in, with consumers being more conscious of what goes into their ingredients, using a culture that you can put on the label and say, starter culture, and it's a live, natural bacteria that's going to help improve your shelf life versus putting a 3-letter acronym that some consumers may not agree with being in their food.
Like BHT and...
Like BHA and BHT. So that's something that's very prevalent for the day and age that we're producing meat products that meet a consumer need.
And fermentation of meat was done before we developed all these additives. Huh? So it was done the same way, with the same bacteria, more or less. Because we isolate these bacteria from meat, from beef meat, or from cheese products, or from washing brine, and we pick these bacteria because of their skills, of the attributes they have, what they can give to us. So we only take the bacteria from a media, we take it, multiply it, and give it in a higher concentration back to control the process on a natural way.
The other thing that I was going to follow up with you is on the thermal processing. So after this 11 days that you mentioned, do you do any extra step for killing, let's say a killing step by doing a thermal processing step, or you don't? Because I know this is some of the big difference, right? When here in the States, we do have a killing step, and in some places like Europe.
No, we don't have at all.
Okay.
We don't have at all. And the Europeans are still alive, huh? So, so no, we don't have. We actually don't have. No heat treatment, no pasteurization step after ripening. No. And we have also shelf-stable product, fermented at low temperature, slowly. A good example is Salami Milano. So original Salami Milano has a fermentation time of 180 days. So that's quite a long time, plus 180 days of shelf life. So we talk for a meat mix for 360 days. And because of the Staphylococcus, you can't store it so long. Because we all know that the fat quality, because of the change of feeding and heat stress, and that the hogs are slaughtered earlier, that the fat quality is not that good like in the past when we had probably a back fat from 12, 15, 20 centimeters. Because today it's probably 4, 5, 6 centimeters, and the texture is much softer. It's much more affected for rancidity. And due to the Staphylococcus, the Italians are still able to produce this traditional way. They are dry fermented. They are Salami Milano. They can stabilize with bacteria without additive fat for 360 days in a shelf-stable environment, so without refrigeration. And that's quite impressive for bacteria, for useful bacteria. So they are not all bad.
Yeah, and I really, whenever I talk about summer sausage and snack sticks, and when you do it right with meeting the water activity and meeting the moisture protein ratio and pH, that you have a shelf life stable product, but you're using other additives to achieve that. And I think I find that interesting. That, I mean, it's nothing new. I mean, Europe, they have done it for a lot of years. Something to have food without refrigeration. I think that's something that, to me, I mean, you're saving energy from that perspective, right?
Absolutely. I mean, if you get your water activity down to 0.85, it's shelf stable without vacuum packaging, and you can just set it on the shelf, and then you've got a pH also that's probably hanging out around 5 or even lower depending on the product. Those two things combined, makes a product shelf stable and be there for a long time. And so.
One of the last things that I want we can go on and on for another hour, but one of the things that I ask you, because I know, like in Europe, you don't use a lot of the mixer grinders that or at least in Germany, you love using the bowl choppers. So we touched on some of the main differences and what would you use a bowl chopper. And I was telling you, maybe, I mean, you do it for, time, more uniformity, right, on the definition, on the particle definition. But I think you were bringing up other things that I think it's interesting for other folks that they're wanting to explore or having like not made a decision yet whether you're gonna go with a chopper or a mixer grinder. What's your take on that?
Yeah, for sure, the most common one in the world, or with the biggest quantities, that's grinding and mixing. Because for the operator, it's quite easy. Huh? You grind your meat to the particle size you want, and you cannot do really a mistake on that. For the grinding, not, but for the mixing, there it starts where you can do a lot of mistakes, and you cause there the base for the final defects. Because when you overmix it, it's the same like with adding the salt. When you do it too early, you activate the proteins by overmixing, and then you create smear. The proteins want to hold, and when you stuff, you have a lot of smear directly under the casing, which is isolating. Then you force also a dry ring, and when you force a dry ring, you cannot lose the water from inside anymore. So that means you don't restrict the bacteria to ferment, mainly the lactic acid bacteria. And then they ferment, and then they run out of sugars. They are stressed, but they have still the AW that they can work properly, and then they produce acetic acid. And often you see then you have a very dark ring because of the smear, and then you have a pale inside, and this is amazing sour. And that it's done not because you choose the wrong meat. No, you overmix it. So that's a big risk. When you use a bowl chopper, you can nearly not overmix because every round more makes a particle size smaller, so that you will see. For sure, it's a little bit more difficult for the operator to hit all the time the same particle size because you need to see it. The machine cannot say it to you, so it's done by the knives and the rounds, nothing else. But the big advantage is that you have a clean cut. So it's not pressed or creased, it's a clean cut. And then you put the particles together, and then you don't have protein bridges, and you can lose the water much, much, much quicker. So in Germany, we do it mainly. We are not the most famous for doing good salami, but we are very famous to do it very quick and very cheap on the plate. And they are good in quality because they are not sour. But we are able to lose the water much, much, much quicker compared to grinding and mixing, just because you have single particles and that we put together. And the water has not even one barrier to leave the product.
Let me stop you there. And you mentioned adding salt last, it's best. You mentioned about 11 days when you do it right. You're not adding last, you can get 2 more days. What happened? I don't know if this, it's good if you don't know, but do you expect some difference in a fermented product when you're using a mixer grinder compared to a chopper? Let's say like more time, or that's something that I may be overthinking.
No, so when you do both in a very good way, they will be very similar.
Okay.
But the tendency that the bowl chopper product is earlier ready, has earlier the desired water loss, that's a fact, will be nearly all the time. And the risk for defects is lower because of that. When you mix, it will be a little bit slower. And when you do some mistakes during mixing, the wrong addition, over mixing, so the wrong row to add your dry matter, so seasonings, salt, sugars, cultures, however, then you could cause more defects compared the way to use a bowl chopper. But like I said, when you use a bowl chopper, you need to be more skilled to hit all the time. When you want to have industrial production, all the time the same product at the end of the day, that's a little bit more difficult for sure with a bowl chopper. You need a trained eye. You need to have some experience.
That takes time.
So kind of jumping off of that a little bit, what is the correct order of addition for when making fermented products, whether it be the quick US way or the traditional European way? When do we need to add the culture? When do we need to add the sugar? When do we need to add the spices? And then when do we need to add the salt?
So for me, the cultures should be all the time as early as possible in the process, in the product. Because it's, for 100 kilograms of meat, we add 600 billion bacteria. That sounds a huge number. That's still 6 billion per kilogram. But we need to distribute them very well because we want to have them everywhere. So that's the reason. So when I would start to do a European salami, I would add the back fat in the bowl chopper, give them 1-2 rounds, add the cultures, followed by the sugar, so the fat can still run and is to the right particle size. Then the lean meat part or the meat part comes, bellies or whatever, shoulders. They comes, you go on with cutting, and then you can add the seasonings because they don't need so much rounds. Normally you have a quite big quantity of seasonings. Important is that you try to distribute them on 1 or on 2 rounds and not half or 1.5 because then you have differences. And as soon as you go close to the final particle size, you should add the salt. And the salt only just for distribution. And for sure you should shake a bit that you give it directly and also there on full round or 2 full rounds and not on half. Because that's also a very classical defect from the bowl chopper that can happen.
So, no protein extraction, just distributing salt evenly, right?
Yeah. So also when you do it with bowl chopper, normally the finished product has something around -8 or -10 degrees, and that means you don't have a product which sticks together in the bowl chopper. It can fall through your fingers, so it's not so dense. It will be dense and be compact as soon as you stuff it, and then you don't have protein bridges and no isolation, and then the product can perfectly release the water. And that gives you time to use your equipment better. Because sure, the example from 11 days and you need 13, when the controller start to calculate that's not sense what you waste. That's because you waste a lot of capacity and energy.
Yeah. Well, I hope this is a lot of information. I hope you guys took some notes. Some of you listening. Thank you for being here today. Thank you for being in Kansas City. Thank you, guys.
Thank you for the opportunity to be here.
Thank you.
Thank you.